Hi, I'm Mr. Franklin and welcome to Conceptual Physics. Today we're going to be talking about the meter and measurement. So let's begin. We've started to explore that the fundamental thing in science is experiment. And it's really important when we're experimenting that we're taking quantitative data, which is one of our vocabulary words, because it's the most objective, and because of that, it's the most desirable type of data. So when we measure a quantity, we need to specify what we measured, how we measured, and in what unit or quantity we measured in. So for example, if we want to measure a length or a distance, we can measure from point A to point B, and that's the length of the object. When we look at distance, we got to realize that it's from one point to another point, but all this space in between isn't important to us. It's just the distance that that person or object traveled. Now, when we're talking distance, we often, if we measure up and down, we will label it the y direction, okay? If we're measuring side to side, we'll label it with an x direction or the x variable. And we'll get into that more because that can be confusing when we start graphing. When we measure, though, we use a lot of tools. Here are some tools that we could use. We're primarily going to use a 12-inch ruler, or we're going to use a meter stick in our labs. But you could use a tape measure. Radar is used to measure distances, and we also have a laser rangefinder on. When we're measuring here in the United States, we're often used to the British system, the imperial units, like the inch, foot, mile, etc. But in science, we use the SI units, which has been agreed upon by the International Bureau of Weights and Measures. So in a sense, that's one of the beauties of science. No matter what our language background is, we can communicate in science with our units of measurement and the quantitative data that we're taking. So, our agreed upon length of measurement is the meter. A sprinter ran a distance of 10 meters. That would be a distance. But we can measure the length of a pole vaulter's pole and say that it is 3.2 meters long. So the meter is a human-sized quantity. It's about 3.2 feet or 39.4 inches. When we look at a meter stick, if we were just to measure with a stick with no markings on it, let's say we measured half a meter. How precise, how accurate could we really be? We could eyeball it, we would get close, but we're just asking for some error in our measurement. So what scientists did is they took the meter and they divided it into 10 equal sections, which is what we call the centimeter. So we got 10, 20, 30, 40, 50, 60, 70, 80, 90, all the way up to 100 centimeters, because 100 centimeters is equal to 1 meter. Well, the same even goes here. What if it was at the 55 centimeter mark? Could we really measure that? Not unless we had some lines for it. So we then further divided the centimeter into 10 equal measurements, known as the millimeter. So once again, the length of these divisions on a meter stick is called the centimeter. A centimeter is 1/100th of a meter. Centi means 100, 1 out of 100. In decimal form, a centimeter is 0.01 meters. Therefore, 1 meter equals 100 centimeters. Or 1 centimeter equals 0.01 meters. Pause for a moment and let's go measure a door's height to the nearest centimeter. So go ahead and do that and then copy down your answer. So did you get a value near 2.12 meters? Notice that our measure was in meters and that the remainder was represented by a decimal. If you measured in centimeters, then your answer would have been near 212 centimeters. However, when the measurement is 100 centimeters or larger, it is always converted into meters. That's really important. When a measurement is 100 centimeters, which is the length of a meter, by the way, or larger, it is always converted into meters. Likewise, if a measure is less than 1 meter, less than 100 centimeters, it is represented in centimeters. So could our measurement of the door be more precise? Sure, we could divide it into, we could use our millimeters that we mentioned before. So the millimeter is represented by the letters mm. A millimeter is 1/1000th of a meter. Decimal form, a millimeter is 0.001 meters. 1 meter equals 1,000 millimeters. 1 millimeter is equal to 0.001 meters. So let's see let's practice making some measurements. So we're going to measure our packet with the ruler with our ruler. So we're going to find the width and the length in meters, centimeters, and millimeters. So go ahead and do that. These are some answers that I got. Compare your answers. Should have got something around 0.21 meters, 21.59 centimeters, and 215.9 millimeters. But notice, did that change? See all these different numbers? Does that mean that the length, the actual width of our paper changes with the changing of the numbers? No. We're picking a scale, which is one of our vocabulary words, that makes the numbers easier to work with and easier to comprehend what we're talking about. So if I see millimeters, am I looking at something big or am I looking at something small? Looking at something relatively small, right? If I see meters, I'm looking for something that's really big. So just keep in mind though, whatever unit we're using, it does not change what that distance is. So if it's this distance, it's always that distance. We might use 33 centimeters, we might use 330 millimeters, but it's still the same distance. With that said, we can measure smaller, and if you want an extension and to explore some smaller units, you can look at the micrometer, which is a smaller unit. The great way to remember micrometer micrometer is to think that we use a microscope to measure those distances. But there are even smaller measurements. So if you click on the link on the video, there will be an extension where I'll show you some other smaller units as well as some of the bigger units that we're not going to use a lot in class. So now that we've looked at things that are human sized and smaller, let's look at the one big measurement that we're going to be dealing with, which is 1,000 meters grouped together, also known as a kilometer. Kilo means 1,000, so 1,000 meters equals 1 kilometer. There's no way we're going to be able to measure something like this with what we have. But you could look in your car. It does have usually a kilometers per hour. It's usually underneath, like on top of a speedometer. If you look in your car, on top is generally the miles per hour, and then underneath in smaller numbers is kilometers per hour. So if you travel to Mexico, travel to Europe, Japan, where I lived, you're going to see signs marked in kilometers and even kilometers per hour. So just to give you an idea of what we're talking about here, look at your meter stick. We said that 1 meter has 1,000 divisions on it, right? Those little bitty tiny lines, 1,000 millimeters is 1 meter. Let's say we pretended that each one of those millimeters is 1 meter stick. Then we could say 1,000 little meters is equal to 1 kilometer. So let's look at some vast distances. These are even outside the scale of the large distances I talked about in the extension video. One of them that we use is called a light year, which is strange because it uses a unit of time, but it's really a distance. A light year is a measurement of distance. It's the distance light travels in 1 year. Okay, so from here to Alpha Centauri, the nearest star, is 4.3 light years, roughly. So it takes light 4 years to travel from here to that star. It takes light 8 minutes to travel from the sun to the Earth. And that's quite a large distance. So we use light years to measure large distances. So, here we are at the end of the notes. Test yourself. Can you answer these questions? If you can answer these questions, then you are ready to move on to the next thing. That's all I've got for you today, and thank you.